Here is lesson 13.2, unit circle, part B. So far we've done a nice job of putting in the degrees, then the radians. Now we're starting to put in the coordinates. When we put the coordinates in, the nice thing about the unit circle in terms of remembering everything is that everything is going to be reflected from one quadrant to another. And to do this properly, we have to remember that, again, in the first quadrant, we have sine and cosine are both positive, just like x and y values in the quadrant system. In the second quadrant, cosines are negative, y's are positive. Third quadrant, negative and negative. Fourth quadrant, x's are positive, y's are negative, or again, cosines are positive and sines are negative. So how does this work? Well, they are reflective. Now, if we just go to the 45-degree ones, since that's what we started with before, they're both the same. So if we reflect that over the y-axis, that's going to have the same values. Root 2 over 2, root 2 over 2. But the difference is, since we're in the second quadrant, the cosines are negative. Then, if we reflect over the x-axis, again we have the same thing, root 2 over 2. But since we're in the third quadrant, they're both negative. And if we reflect it over the y-axis again, whether you go from there or from the top down, makes no difference. We still have root 2 over 2. And since it's in the fourth quadrant, the cosine is positive and the sine is negative. And this is how we will fill out everything else. We have the information we need. Now we just have to remember how the signs change. So if I go to 60 and reflect over the y-axis, now I'll have 1/2 and root 3 over 2. But again, since I'm in the second quadrant, x is negative. If I reflect to 30, I'll have root 3 over 2 and 1/2. And again, first one's negative. And follow that pattern. So I'm going to, since I just did 30, I'm going to finish the 30s. Reflect that down below. Both negative. Bring that all the way to the right. Sorry about my 2's there. It glitches on me when I write it. There we go. And that is the y is negative. Okay. Finish the other ones. Here we have 1/2 and root 3 over 2. Remember, the two values swap. And now we filled out the unit circle for sine, cosine, all the way around. Now we have had one more trig function that we haven't done yet, and that's tangent. And again, we had values for tangent on our special right triangles. And that was tangent of 30 was root 3 over 3 And then here it was 1. So in black, tangent will be black, okay? So here tangent is 1. And then for 60, tangent was root 3. We basically use the same idea of mirroring those. Okay, tangent is basically, if we haven't thought about this yet, tangent is the same as slope, which is rise over run. In this case, sine over cosine. So if they are the same sign, if sine and cosine are both positive, then tangent will be both positive. If sine and cosine are both negative, then tangent will be positive, because negative divided by negative. If sine and cosine are both different signs, then you have a negative tangent. So if in the first quadrant, sine and cosine are the same, so you have positive tangents. In the second quadrant, they are different signs, so the reflections will be negative. Again, I'm just reflecting them across the y-axis. In the third quadrant, they're both negative, so we will have a positive tangent again. Fourth quadrant, they're different signs, so I will reflect, and again, they will be negative. On the axes, if tangent is sine over cosine, then for 0, tangent will be 0 over 1, so tangent will be 0. At 90 degrees, tangent will be 1 divided by 0, and that is undefined, so tangent will be empty set. At 180, again, 0 divided by negative 1, so you'll get tangent of 0. At 270, negative 1 divided by 0, so tangent will be undefined, and that is called a tangent. So the power of the unit circle is to memorize a lot of information in a visual way so that you can find out what trig function values are without a calculator, and they give you the exact values. So if I asked you what is the sine of 150 degrees, at 150, sine is right here, so it's equal to 1/2, and you can check that on your calculators. If I want to find out what the cosine of 7 pi over 6 is, I find 7 pi over 6, which is right here, and cosine is the x value, so negative root 3 over 2, and we have our answer in exact form. Our last part of this is the very bottom of this, or the next screen, or this one, let's see, next screen, and a coterminal again. And to do that, I think probably the best way to see this is to change this radian into degrees. And if you remember, that would be taking it times 180 over pi. Pi's cancel. 3 goes into 3 once. 3 goes into that 60 times. And if we do that, we get 420 degrees. So if you draw 420 degrees, this is 360. So if you take 360 away from 420, you get 60 degrees. So a coterminal degree for that would be 60 degrees, or pi over 3. That's another way to look at it. And this ends the lesson for unit circle.